Good morning, children. Let us continue with the first chapter, Motion, Force and Machines. Previous class already have explained about the introduction of motion, force and other things. Now, once again I will just read it so that you will understand, and then I will continue with motion. Have you ever played the game statues? Isn't it fun to stand like a statue for a few seconds without showing any sign of motion? This I have told you last class. Not even the blinking of eyes. Oh yes, it's tough too. Motion is an integral part of our everyday life. In fact, the ability to move on one's own is a characteristic of living organisms. See, even my scale is moving here, my hand is moving. This is what we call it as the motion. We walk, jog, run or jump to move around. Birds fly in the air and leaves on a tree move in response to the wind. See, with leaves I told you they cannot move directly until and unless there is certain force. What is that force here? It is nothing but wind. Objects, however, need to be pushed or pulled to put them into motion. Now this is an object. It cannot move until and unless I just apply some force for it. For example, in the game of hockey, players pull the ball from their opponents using hockey sticks and try to push it to the opponent's goal to score a point. Engines need to pull the bogies to move the train, while a car which has had a breakdown needs to be pushed to move it. Push or pull is a common name given for force. So either it can be pushed or it can be pulled. Only then the object can move. So it is impossible to lift and carry all the goods in our hands. So if there are small things, so what happens? That can be easily carried, but heavy objects cannot be easily carried, especially when you go to shop for provisions for a month, then it is not easy. So what to do? In that case, actually see, that's the reason why strollers means like trolley you carry it, no? Strollers which make the task of carrying goods around easier are a common sight in supermarkets. As is evident from the example, we use tools or machines to make our work easier. See, we are using trolley. Trolley is a machine. If that machine is not there, only your hands are there, means what happens? You cannot lift it easily. But if there is trolley, whatever, and there are wheels, so what easily can move your provisions. In this chapter, we will learn in detail about motion, force and machines. Now, let us see motion. An object is said to be in motion if it changes its position with respect to its surroundings in a given time. So, when there is an object is under motion, if there is change in its position with respect to its surroundings in a given time. Now, this is an object. Now, what happens? You have to push it. See, like this, if you do, what happens? There is a movement. If not, it cannot move. So what is said here? It is changing its position. Now it is straight. What's happening? It's going to the left side. Now it's coming to the right side. There is a change of position with respect to its surroundings in a given time. So now if I do like this, what happens? Time is faster. Isn't it? Now if I take like this, it is slow. So based on the time, what happens, and based on the surroundings, the objects can move with the help of a force. When you are going to school by bus, do you observe any change in what you view through the window? Buildings, people, trees, etc. seem to be moving by. This change of view indicates that the bus is in motion. See, when you go by bus or car or whatever it is, what happens? When the bus or car starts moving, you see, when you look through the window, you see the objects outside also will be moving. Actually, the objects are not moving. Because you are moving forward, what happens? You feel that the objects on the either sides are moving backwards. They are not at all moving, they are all stable. Because you are moving, you feel that they are also moving. That is what we call it as a motion here. Next. Now let us see about kinds of motion. So there are different ways in which objects can move. What are the different ways where the objects can move? See, first one is called as a linear motion. Linear motion means an object is said to be in linear motion if it moves in a straight or a curved line in a single direction. So when it is moving in single direction, now I am walking like this. So what happens? Now this is called as linear motion. So it can be in one direction. Either it can be straight or it can be curved. But you are moving in one direction. Then you call that as a linear motion. A ball dropped from your hand, a football rolling on the ground, and a vehicle moving on a straight road are all examples of linear motion. Now you can see I have got a chalk in my hand. I am dropping it down. What happened to the chalk? It is moving straight down. So that is what we call it as linear motion because it is moving in one direction. A football rolling on the ground. You have a football. If you just kick it, what happens? It will start moving either straight or curve or whatever, but it moves in one direction. It will not come back. So then that is called as a linear motion. And a vehicle moving on a straight road are all examples of linear motion. Hope you have understood now. Let us see. See, linear motion. Linear motion is when there is motion in a straight or curved line with all body parts moving the same distance at the same speed in the same direction. Means now for example if I am walking, my whole body has to walk in the same straight line or curved line. I can even move like this. But the whole body has to move in same direction. Then you call that as a linear motion. Tobogganing, this moves in a straight line, the same distance, in the same direction, at the same speed. So like that, shot put also you can see the shot moves in a curved line, the same distance, direction and speed. So all these things are the different types of games which is moving in one direction. So examples of rectilinear or linear motion is, see an apple falling from a tree. Can you see? Due to the gravitational pull, what happens? The apple moves always down, it will not move upwards. It is always moving down. Pushing of a box. You cannot just push up front and back. So what happens? See, you can see only pushing of a box. This is a linear motion. March past by student on straight path. So there is a track. You can see the tracks here. And they move in the same tracks forward. They don't move backward. They move forwards. So this is also an example for linear motion. Now next let us go for circular motion. Circular motion, the name itself says circular. It is moving round. An object is said to be in circular motion if it moves in a circle. Some examples are the hands of a clock, a rotating wheel and merry-go-round. So see, if you just put a top, what happens? The top will start moving round. So that is what we call it as circular motion. So you would have seen merry-go-round in the parks and all. You can see in schools. You can see a clock. Everybody knows what is a clock. In the clock also you can see the hands moving in round. So that is called as a circular motion. Let us see the other examples. Yeah, circular motion examples you can see here. Sun and planets. So you can see the sun here. This is sun. And these are all planets. So what are the planets doing? You see these planets are moving in their own orbit which is circling the sun. Sun is not moving, but you can see the planets moving around the sun. So this is what we call it as the circular motion. For example, if you take Earth, Earth also moves around the sun in its orbit and that causes the revolution. And this Earth will rotate in its own axis here. There is an axis here. In its own axis also it circulates, that causes rotation. So like this you can see circular motion. Earth and moon. So what happens here? The Earth is there. Moon is the satellite of the Earth. What does the moon do? Moon also will be rounding the, what is this? Earth. So moon is a satellite. It moves around the Earth. Now let us see atom and electrons. So you can see this is the shell. Electronic shell. So what happens is the atoms move in the electronic shell. This is called as a electronic shell. So like this it moves. So atoms and electrons also move around. Coming to circular track. So you have seen in Olympics and other things wherein you can see the stadium with full of tracks, and how the tracks are constructed is in the circular form. So like 800 meters, 1000 meters, 2000 meters, like that it will be there. So it is constructed in a rotational form, or what we call it as a circular form. So this is circular track. Circular ride, giant wheel. You would have seen the giant wheel. So in the giant wheel also you see the movement will be in the circular form. So this is circular motion. Coming to oscillatory motion. So oscillatory motion, an object is said to be in oscillatory motion if it moves to and fro along the same path. A common example is the motion of a pendulum of a wall clock. Other examples are vibration of atoms of a solid and the motion of a string of guitar when plucked. See here, oscillatory motion means now this is the scale. So what I do, I just do like this. See, it moves like this. See, moves like this. This is called as the oscillatory motion, wherein there is no particular time here, but here what happens in this pendulum of a clock, you would have seen earlier in the olden days, and now also it is there. Different clocks will be there, and there will be a bell-like thing which will be moving, isn't it? So you can see even nowadays you have seen that different types of birds and animals and all coming out after 1 hour in the clock, and they make some sound, you know. The same way there is a pendulum also which moves at 1 hour or half an hour. So that is what you call it as, and that will be oscillating. This is oscillating motion. So, but here you see an object is said to be in oscillating motion if it moves to and fro along the same path. It has to move in the same path. Then a common example is the motion of a pendulum of a hall clock. So you have seen that pendulum, for every half an hour or 1 hour it just makes the sound by its movement. Other examples are vibration of atoms of a solid. Already you have seen this in the previous one. Atoms of a solid and the motion of a string. Means that you cannot see the motion, but what happens in solid, supposing now for example, you are keeping a spoon in a hot water. What happens? First the portion of the spoon which touches the water will become hot. But later on what happens? Till the end, the last end of the hand of the spoon also will become hot. How is it possible? Because the atoms which are present in the solid are going to vibrate and then they will hit the other atom, and that atom will hit the other atom. Like that it becomes hot. So that is all called as the oscillatory motion. Now if you take a guitar, what you do? There are strings in the guitar. If you just pluck it, what is happening? You see the movement of the string. So that is again we call it as the oscillatory motion. So let us see the example for oscillatory motion. And then coming to the periodic motion. Motion which recurs at regular intervals of time is known as periodic motion. Example are the swinging clock pendulum, revolution of the earth around the sun, and our heartbeat. Now in the periodic motion means particular time. Here there is no actually particular time, but here you can see the particular time. Here there is particular path, but here there is particular time also. So what happens here? You see it moves in a same way, in the same path, but it has got particular time here. Now, example they have given here, the swinging clock pendulum. So, in the pendulum, I told you about the clock, wherein the this one, what is that knob will be just moving, and it moves in a particular time. It has got, if it is minute means minute, hours means hours, second means second, like that it moves. So, that is called as the periodic motion. So, here what happens? And revolution of the earth around the sun. So, revolution of earth around the sun, it is 1 year, that means 365 days. So, every time it is 365 days. You cannot change it at all. So, that is also you call it as periodic motion because there is exact time for that. So, that is periodic. And our heartbeat. Normally what happens? In small children, the heart beats little faster. It may be around 75 to 80 times per minute, but in adults it is around 70 to 72 times per minute. It cannot go beyond that, or it cannot be less than that. So in the normal person that happens. So there is a particular time for that. So that all comes under periodic motion. Now let us see the examples. So periodic motion, when the same motion repeats itself after equal intervals of time, we call it periodic motion. See, when the same motion, movement will be the same. What happens? When the same motion repeats itself after equal intervals of time, we call it periodic motion. So every interval, it may be 1 hour or half hour or whatever it is, it will follow the same time throughout. So that is called as a periodic motion. You can see here. So here what happens, you can see the clock. Here you see the moon rotating around revolving around the earth. It is a satellite, already I told you. It has got particular time here. And now if you see, this planet earth is moving around the sun. That also has got particular time. So this is called as periodic motion. So now let us continue with the speed. So the types of motion is over. Now let us see about the speed. The speed gives us a measure of how fast or slow an object is moving. So what does the speed means? Speed means either it can be slow or fast if an object is moving. So it has to move either with one speed, either fast or slow. A fast moving object has a high speed while a slow moving object has a low speed. If there is no movement, we say the speed is 0. Now, for example, see, this is an object. What happened? It has moved faster. Now, the same object, what's happening? It is moving slow. So, this is what we call it as the speed. Either it should be fast or slow. Now, this object is standing like this still. What happened? This is what we call it as the speed is 0. There is no speed, it is 0. To find out the speed, we have to divide the total distance travelled by the total time taken. The total distance travelled by the total time taken. So, now this is an object. What is happening? It has to move from this place to that place. What to do? Now for example, see here, this has to move till that end. What's the time taken? How fast it is going? See, if I just move like this, what happened? It is fast. So what is the time taken? Time taken also will be fast. But if the same point if I have to reach, so what is happening? So what happened? The distance may be the same, but the time taken is slow, isn't it? So that is the meaning here. Speed means distance covered by time taken. So what is the total distance covered and what is the time taken? Now for example, see here. The unit of distance or length is meter and unit of time is second. Hence, the speed is mentioned as meter per second. So speed is nothing but distance covered by time taken. So if you want to move some distance, what happens? It is measured in terms of meter if it is small distance. If it is small distance, you measure it in meter and the time taken will be in seconds. Hence the speed is mentioned as meter per second. Distance is measured in kilometer to minutes and hours and day are used to measure the time. So distance is measured in kilometer to minutes. You have to move in kilometers. Now this, if I just have shown you this movement, this is meter movement. How much takes? It is taking only seconds. This movement takes only seconds. So meter per second. If it is moving a little longer distance like kilometer, if it has to move in kilometer, what happens? The time taken here will be either minutes or hours or a day. For example, now from here if you are moving just to see this school is situated at Kempegowda Nagara. So from Kempegowda Nagara you have to move little till Sunkarkatte. You are moving in kilometers. Okay. And the time taken here you cannot count it in seconds. You have to either count it in minutes. Now from here you have to go to Mumbai. When you have to go to Mumbai, what happens? The time here you have to take into kilometer, but you cannot count it as minutes. You have to go for hours. Now you have to go to Delhi. what happens? You have to count it in days. Did you understand? This is the meaning here. So the distance is small, then meters and second. If distance is more, you have to take it into kilometers, and that will be counted in time like minutes, hours and day. So whenever we mention speed, we must mention the unit of distance and time. So only one point you have to remember here. Short distance means meter per second. If it is longer distance means you have to take either in kilometers with minutes, hours or day. That's the difference. So totally speed means nothing but distance covered by time taken. So children, let me stop it here. We will continue in the next class. Thank you.